Okay, this video should have been about the Romer-Lewin ring made of two inductors, and in a way it still is, but I have encountered a few problems, a few complications due to the amateurish equipment I'm using, and also the low-cost components. I'm a bit stingy, and I need to set the stage for the measurement and show how I will use one of my voltmeter, this lower one, to recover the actual measure of voltage so that I can show both measures at the same time across the ring. Now, the main reason, though, is that I wanted to show that the self-inductance of the ring itself is negligible. It will not contribute to any amount of value to the actual voltage measured by the instruments. Okay, let's start by taking the self-inductance of the ring out of the loop, so to speak. This is the formula to compute the external self-inductance of a circular loop of wire, given radius and thickness. It assumes the conductor is a circular section, and by plugging in the values, a few numbers, we get, for example, that a ring with a diameter of 10 centimeters and a cross section of about 1.7 square millimeters will have an inductance of just less than 270 nanohenries. That's very small. For example, at 50 Hertz, this corresponds to a reactance, to an inductive reactance of just 84 microohms. At 1 kilohertz, it's 1.7 milliohms, and at 4 kilohertz, it's 4 times that, less than 7 milliohms. With the currents we are using in our ring, the current that flows due to the low EMF I have in the toroidal core, these reactances will contribute a negligible amount of voltage to the total, so they will not change at all what is read by the voltmeter. So the self-inductance of the ring is not responsible for the voltage we will read on the voltmeter. One more thing about the self-inductance of the loop. As I said before, the reactance at 50 Hertz is minimal, and it still is negligible at 1 kilohertz and 4 kilohertz, the frequency I will use for the experiment. But all of this is in vacuum or in air. The presence of the core can alter the value of the inductance considerably. If it is done right, it could raise the inductance of 1,000 times, even more. But this is not the case, because I performed the experiment with the resistive ring, and I observed that even at 4 kilohertz, with considering the core, the effect in terms of voltage is less than a few millivolts. The main problem I had to solve was that with inductors, with resistors and capacitors, I was able to use the mains voltage at a frequency of 50 Hertz because I had components with large enough values to give appreciable voltage drops across them. The inductors I have at hand right now are too small to give appreciable reactances at 50 Hertz, and their parasitic series resistance is so big that it becomes comparable to the value of the reactance. And this will change the phase lag, and it will create a lot of problems. So 50 Hertz was was not a viable frequency. I had to raise the frequency, but before doing that, we might want to see what would be possible if we had very ideal inductors.